Hello, and welcome back to Political Science 4781, Techniques of Political Analysis. In this series of videos, I've been talking about what I call a few of our favorite things, that is, exemplary data visualizations. In the last video, I talked about parts of a whole, that is, visualizations of how it is that a number of smaller things make up some larger thing. Today I'm going to be talking about spatial distributions, that is, visualizations in which space is a major or useful design element. Then in the next video we'll talk about time, and after that relational visualizations, and finally narratives. Now, when we talk about spatial distributions and spatial visualizations, one of the very first ones that I have to mention is this one from Facebook. It's a visualization of Facebook friendships worldwide, where the lines indicate a connection between one Facebook user and another Facebook user. And one of the reasons I like this visualization so much is that it reminds me very much of a political scientist from decades ago, Carl Deutsch, who was interested in figuring out where states formed communities. That is, where, and by states I mean countries, states in the interstate system, where you could expect to find sets of countries that have more affinity than you would expect just to randomly, or a set of randomly chosen states to have. Now, there are obvious indicators of affinity, something like NATO, for example, at least during the Cold War, was a pretty good indicator of a set of countries that formed a community, and among whom sort of the expectation was that there wouldn't really be any violence between states. And that, to Deutsch, was really interesting. He thought it was something that most theories of international relations missed, that there were sets of countries out there that just, when they thought about what their options were, fighting wasn't really even potentially on the agenda as a way of resolving their disputes. Now, the way that Deutsch set out to measure communities among states was to take a look at mail flows. That is, the volume of personal mail going from one country to another country. This was decades ago, so the internet didn't exist, email didn't exist, Facebook didn't exist, and he came up with the idea of going out and finding measures from national post offices of how many pieces of mail from each country went to other countries, and using that as an indicator of affinity for one, or community. Now, I love this example because anytime someone comes to me and says, I want to measure something, but it's not as easy as GDP per capita. It's not like I can just go to the Wikipedia page or some other source and figure out, what the right number is. I can't just sort of hold my hand out and have the data fall into it like a ripe plum. This is a great example to say, there are a lot of different behavioral implications of whatever phenomenon it is that you're interested in. If you want to measure community between states, that's probably going to have a footprint of some kind. And you need to think about, what kind of behavior would be implied by states forming a community. What do you mean by community? What are the implications of that you might be able to measure? And Carl Deutsch was fantastic at dreaming up ways of measuring concepts that interested him. They weren't always the most practical ways, but they were at least feasible. So Carl Deutsch would have gone nuts over this visualization. He would have thought it was just fantastic because it shows. Now, obviously, you're going to see lots and lots of Facebook friendships between Hawaii and the U.S. with the same country, but you see a pretty significant number between the U.S. and the U.K., for example. Lots and lots between U.K. and the rest of Europe, and that subset of the graph would probably be fascinating just to pull out and dissect on its own. You see a fair number between the Iberian Peninsula, Spain and Portugal on the one hand, and South America on the other, you actually see a lot more activity within Portugal than you do within Spain, so much so that the two countries can be readily identified just based on Facebook friendships. And you see a lot clearly between the U.S. and Latin America. So it's a terrific visualization. It's pretty clear what it tells you. You can figure out very intuitively just by looking at it what it means. You can get a lot of information out of it. It summarizes a huge quantity of information. It's gigantic. It's sort of the worldwide Facebook social network is what's captured here, and it does it in a compact visualization that's easy to understand and fascinating to explore. So this is one great example of the kind of thing you can do with a spatial visualization. Now here's another one. It's not compelling on the scale of the Facebook social graph by any stretch of the imagination, but it's very handy if you happen to live in San Antonio. And as a matter of fact, I wish Columbus had maps of road rage incidents, because I would probably avoid areas that had fairly high concentrations of accidents due to road rage. Now, you wouldn't necessarily avoid them because you think somebody's going to try to run you off the road, although that's certainly, apparently, according to this map, potentially an issue. But whatever's infuriating them is probably going to infuriate you as well. And you never know. I mean, it could very well be just better to avoid these sorts of areas entirely. Now, it does raise a couple of questions, this map does. And it's actually a good example for both do's and don'ts in some regard. You don't really have a sense of what fewer and more means. I mean, is more incidents 3 incidents, 4 incidents, 5 incidents over a period of 5 years? You don't really have a sense of how serious the problem is, except in a couple of spots. You've got 21 in one area, 13 in another, but the scale isn't really clarified when it says more incidents to fewer incidents. Another is that you get this sort of bleed over characteristic that is that's pretty common in heat maps. And if we when we get to the week on plotting heat maps, you may discover this for yourself, and I've certainly discovered it when I try to plot heat maps for data within countries. Sometimes I'll find that the heat maps are broad enough, or the blobs in the heat maps are broad enough that they run over the boundaries of the country. Now, here you can see that there are a fair number of apparent road rage accidents that don't actually happen right on the road. They seem to happen pretty close to the road. And that's clearly not the case. It's just the fact that a heat map produces blobs that are a little bit spread out, and so that's kind of one of the downsides to heat maps. One way to solve that, which is shown in the next heat map, and this is a crime map of Columbus from Trulia, is if the area that you're looking at can be broken down usefully into grids or smaller geographic areas, don't allow color to bleed over from one area to the next. Just color each area in proportion to whatever it is you're trying to measure. Okay? Now, in this case, we've got blocks, city blocks, and you can measure the number of crime incidents of various kinds, and these are individual crimes that have occurred over the past 6 months, and you can assign a color to that area based on the number of crimes that have occurred there. So what you can see when you take a look at this, first of all, if you're in the university area, there's a big difference between being west of High Street and being east of High Street. That is, a lot of the crime that you uncover in this heat map is in the Wineland Park and Italian Village area, although it sort of evens out once you get south of the University District, and you see some crime bleeding over into places like Victorian Village in the short north. And you can also see, you can look downtown and to the west of downtown and see which blocks are more crime prone and which ones aren't. So it's a good representation. The heat map is kind of the workhorse of spatial distributions, I guess I'd say, in spatial visualizations. And this one's done particularly well in that you get a very clear sense of where issues are arising. There's another visualization that's worth taking a look at in Franklin County. It's the number of people who come in versus the number of people who come out, but also where they come from and where they go. And despite the fact that the lines are colored over one another, which is a little bit frustrating, you can figure out pretty quickly, looking at this, that we tend to draw people from pretty nearby and send them all over the country. And this isn't, I guess, too much of a surprise, given that we're a county that has a major state school and research university in it. We bring a significant number of people from in-state, and to their mother's considerable chagrin, spread them all over the country. But it's an interesting pattern to see. It's also interesting to see the surprising number of people leaving Columbus to head to Florida. I would assume that professors who are retiring make up some proportion of that of those emigrations, but I'm not entirely sure. Okay, another visualization that uses space in kind of an interesting way, more of an organizing manner than anything else, is this map of the world that shows each country is represented as the most common word in its Wikipedia history entry. Now, there's nothing particularly spatial about this information, but the interesting part of the graph is that space is used as a way of organizing the different words that represent something about the history of a particular country. You can get some, spatial information out of it if you compare African countries to the adjacent African countries and see which ones say French and which ones say Italian and so on and so forth. You can get some spatial information out of it. But for the most part, here space is used kind of as an organizer to hang other information together, which is it's not sort of the standard information like GDP per capita or population, but something more qualitative about the country. So it's a pretty interesting use of space. Here we have one of the more standard kinds of maps that I was just discussing. There's a straight-up demographic map showing you where populations are. The interesting thing here is that in addition to color being used to indicate, higher concentrations of people, height is also used. You've got an extra dimension. Most maps are two-dimensional, and this one decides to flip a two-dimensional map on its, to some degree, on its edge, and show it and use the third dimension to represent information. And that's a pretty cool idea, because in most standard two-dimensional heat maps, it's pretty difficult to figure out exactly how the colors are calibrated, and it's not always immediately obvious, how much bigger or how much denser a red area is than a yellow area, and so on and so forth. Here you can see it's a linear scale. If you've got a country with half the population of New York City, the spike is half as high. There's a bit of a downside in that spikes hide things that are behind them. That's part of the reason that they're such narrow spikes. But if you are, a city right behind New York City, you're not going to show up on the map, unfortunately. But still, it's a really interesting and memorable visualization of distribution of population density. A couple more. This is a collection of census data, and I think each data point represents 10 individuals, and they're geolocated by the census location. Normally you don't use something as small as a dot like this in a data visualization, but the way that it's done here, it's really cool because the degree to which the dots are concentrated give you a sense of population density, and they're different colors, which give you a sense of ethnic distributions. Red dots are Caucasians, blue dots are African Americans, green dots are Asian people, orange dots are Hispanics, and actually in my notes here it says one dot is 25 residents rather than 10. So a handy map and a very compact visualization of a lot of interesting data. Finally, I didn't know the NBA kept data on how many attempts are made from a specific area on the basketball court and how many points per attempt were registered, but in fact they do keep that information. And what you can see looking at this map is that people take a lot of shots from sort of the 90-degree points, the hot corners, as well as the 45-degree points, both inside and outside the three-point line. And of course, right underneath the basket is incredibly productive in terms of points per attempt. So this is again a very compact way of it uses the spatial representation of the basketball court to organize the information about how often. It's got two dimensions of information. The size of the hexagon tells you how often people attempt shots, and the color tells you how many points they get. So it's a very compact visualization. Now, finally, I'm going to show you a video of CNN's tweet map after the 2000 State of the Union address. It's a great example of real-time spatial data analysis. What they tried to do was get a sense of the public's reaction to the President's State of the Union address using a company called Crimson Hexagon that does analysis of tweets in real time. And it turns up some very interesting results. The one thing that I'd point out that I would change is the flagrant use of pie charts, which, as most data visualization people will tell you, are a very, very, very bad thing. And I'll explain that more in subsequent lectures. But for now, I'll just show you CNN's tweet map following the 2011 State of the Union address.